Here we go. So the first one, find the measure of angle A. So 1 mark for the diagram, if it's done correctly, right? So you should have seen that there's a pair right off the bat, 50 degrees, 29 centimeters, and we have 27 centimeters here. And this one is as easy as it gets, right? Sine of 50, so I might skip through some of the work. So sine of A is across from 27. So if you have that set up, you get another mark for that. And sine of A would be 27 times sine of 50 divided by 29, right? Which gives you 0.713, and it keeps going. So angle A is, this is the one I want to see, right? That angle is the inverse of whatever you got here. So angle A is 45.50 degrees. Yeah. You went from here straight to here. No, what if you just wrote sine inverse? Yeah, so that's a good point. If you just go from here and then just have that like that, right? That's technically not accurate because you're saying sine of A is equal to sine inverse of that. As soon as you have sine inverse on the right side, then technically the sine disappears next to A or whatever angle you have. So I would go N like that notation. If you that's a half mark deduction when I see that. So today I would say just be honest with it, not a big deal. It's not a concept, it's just a notation, annoying part, right? There we go, so that's A. And then DEF, sorry, so 1 mark for diagram, 1 mark for setup, and then 1 mark for the correct. So that is actually out of 3, right? And then we have another triangle DEF, so I'll try to sprint through this one if I can. So 62, 58, and this is 7.5 here centimeters. You've got 2 angles, find a third right away. So you got 1 mark for the diagram. Figuring out angle F, that's 60 degrees. You get another mark for that. And then set up, right, sine of 60. This angle is across 7.5. So sine of, what is it that you want? E. So sine of 58 over side E. You get a mark for the setup, and there needs to be a bunch of work. So E is 7.34. It's slightly smaller, slightly shorter side, and it makes sense because the angle across from it is a bit smaller, right? So you get another mark for that. So 1, 2, 3, 4. That one is worth 4 marks, okay? And then next, X, Y, Z. Determine angle X, so, no, sorry, side X. X, Y, Z, like that. And you put the numbers where they, let me see here, 79 is the angle X here. And I'm given this. And I'm given this. And so this is the side that obviously is, I need to solve for. You should recognize that it's cosine law, right? Side, angle, side, right? So 6.38 squared plus 2.75 squared minus 2 times 6.38 times 2.75. And I'm going to run out of room here, but I will make it work. Oops. So X is equal to, you type all of this in one shot. So at that point, as soon as you have the square root, you should not have a square there anymore. Okay? That would also be a notation error. So X is 6.45 centimeters. So 1 mark for the triangle, 1 mark for the correct setup, and then 1 mark for actually solving everything. So 3 marks there. So we are out of 10 on this page. Okay, 10 marks for this page. And now the fun begins, right? So triangle fun, we have the sides are as follows. I'm just gonna look at my key here for this one, right? We have all sides there. They want the largest angle, which is across the longest side. So technically you should start like this. Cosine of n. And remember, I go like this, and at the very end, I go 0.8 squared first, and then I worry about the other two. 0.5 squared plus 0.4 squared. Right? I insert the other two sides, and then at the bottom is 2 times the first one times the second one. That gives you negative 0.23 as a numerator, and then you should be like ding, 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 right? That tells me that I'm expecting an obtuse angle. So angle N is cosine inverse of, you can actually type this whole thing in here if you'd like, or just turn that into a decimal, which is this. It actually is a finite decimal. So that's 125.1 degrees for that one. So 1 mark for this diagram, 1 more mark for the setup, and another mark for the correct final answer. So this question is worth 3 marks. And here's the other one, right? The one that was probably the most challenging of all. So you have a plane, right? And nope, sorry, not that one. This one. A plane spots the airport, right? At an angle. At first, you should have just been like that, right? The angle of depression is always measured like this, 23 degrees, right? But that plane continues to fly until that angle of depression, right? So the plane continues to fly for 3.45 kilometers. Okay, and where do you put the angle of depression? Well, that is the problem here. This is the angle of depression, right? 55 degrees out there. So I would say if you have this exact diagram already with a 55 out here, I would give you 1 mark at that point. And I would strongly suggest you adding angles, right? ABC or something like that. And here's where the fun begins, right? I'm going to find that inside there. That is angle ABC. I don't know if you remember 3-letter notation. Here it is, right? 125. If you have that 125, you get a mark. That's the concept of supplementary angles. So that's 125 out here. And I still don't have anything here. I have angle, side, angle, right? This simply gave me the angle inside the triangle. I still need to, I'm trying to get a pair here. So angle C is 180 minus 23 minus 125, right? So I'm taking the 2 angles inside away from 180 to give me that angle C down here. And that is 32 degrees. You get a mark for that as well. So 1 for the diagram, 1 for the 125, and 1 for the 32. So far, it's all just adding and subtracting, right? And here's where you have your pair, right? So this is your pair. So sine of 32 degrees over 3.45 is equal to, and what do I want again? Calculate the distance between the plane's current position and the airport. So this is the side that's unknown here, right? So I need to use sine of 23 over x. And obviously you need to show me a whole bunch of work here, but I will go straight to the answer, which is 2.54 kilometers. So I will give you 1 mark for the setup and then another mark for the correct answer. So this whole thing is worth Okay. Diagram 125, 32, setup, solution. Just handing out marks today. On a test, I give half for a lot of the steps, but I think it's easier on the AC. If you get 5 out of 5 or 3 out of 3, you're still getting 100%, right? It's the same thing. Let's go to 7, triangle ABC. A is 46 degrees. Oh, C is the base of that triangle, so I have to watch out, right? Because it says that, I need to put C up there. Good catch, right before I... So it's okay to go ABC. Remember, I told you clockwise, counterclockwise, it doesn't matter. But in this case, it's very specific that you want the 51.5 centimeters to be the base. And B is 42.9 centimeters. So if you have that diagram, 1 mark. And so for area, we need the height. So the height of this thing is 42.9 times sine of 46. And let's see here. 42.9 times sine of 46. That's 30.86 centimeters. So let's say you didn't catch this. Your height is then probably 51.5, right, times sine of 46. So you got 37.05. That's, you lose a mark here with your diagram. I would still give you a mark for the height, right? So anyways, the height itself, that work gets you 1 mark. So 1 for the diagram, 1 for the height, and here's the other one for the area. 51.5 times 30.86 divided by 2. $794.65 centimeters squared. What's that? Yeah.
I put 4 decimal places for the height, and I got this 0.01 off.
Oh yeah, that's fine. Okay. Absolutely. Yeah. Yep. That's technically how it should be. If possible, use everything before you get to your final. So 1 mark for the area, of course. So we are out of 3 for that question, right? So 3 and 5 is 8. And another 3 is 11. So this page is out of 11. 1, 2, 3. So we are out of 21. Okay.